Okay, good morning. Welcome to
SuperMath number 21.
SuperMath21. So we have been talking about isosceles and equilateral triangles, and one of the homework problems you did yesterday actually was this proof. If you have a triangle and you have two sides are the same, prove that the opposite angles, angle B and angle C, are the same. Okay, can you walk through that proof, please?
Alright, so I'm going to draw this line. That's the midpoint of line BC.
Okay,
I'll just call this point X.
all right.
So, I have these two triangles, which are the same because of side congruence.
Okay. So you have two triangles here,
They're congruent.
AXC and AXB, and they're congruent because all three of their sides are the same. Alright?
Yep. So, if they're congruent, their angles are the same. So, these angles are the same. These angles are the same. And these angles are the same.
Okay. So if they're congruent, we can match them up
Match up.
in the correct order, and their angles will be the same. Okay? And that's really the proof. It involves just being able to draw this line that cuts from this point, that cuts this line in half. Now, are we always going to be able to do that? Cut a line in half?
Yeah, I think, unless the line goes on forever.
Right. Okay, good. So, because it's finite in length, it has some length. We don't know what that is, but we could call it m, and then m over 2, m over 2. That's the point. Okay. Not bad. Now, what about what seems to be sort of the opposite of this? What if the angles are the same? Prove AB equals AC. Okay, so now we have the same, or I shouldn't say the same, a similar setup. We have a triangle A, B, C. And now I know this angle and this angle are the same, and I want to prove AB equals AC. Okay, so how do you do that? How do you go the other way?
Well, we're going to need a different type of congruence. Maybe our line will help us, but we can't do side congruence because we're trying to figure out this.
Yeah.
And we'd need these angles if we wanted to do angle side angle.
Okay.
Well, if the line's the midpoint again, you could sort of say the same thing, but you don't have a congruence matchup yet.
Right.
We need this.
See, if you make it the midpoint, you have side angle,
Which
being the
doesn't
same,
always work.
which doesn't always work. That's the problem.
So let's make it perpendicular. We can make it perpendicular to this line.
Okay, so we can, from a point, we can draw a perpendicular. Okay. What happens now?
Well, we have two angles. This one's also 90. So from these two angles, this third angle up here, these are the same. Just two dashes.
Okay.
Because if you have two angles that are the same, these two can't be different.
All right.
So these triangles are congruent.
Whoa.
Wait,
By
no.
what formula?
Wait a minute, no, they're not.
Angle. Does that mean congruent?
No, but you have this congruence. You have angle, side angle.
Ah, okay. We have all three angles the same. Does not mean the triangles are congruent, but they have a side that's the same. So we have angle, side, angle, and that makes the triangles congruent.
So the sides are the same.
So the sides are the same. Okay, so going from the sides to the angles is one proof. Going from the angles to the sides is a different proof. And it relies on the fact that from a point to a line, we can always find a perpendicular. And that's it. So that means in an isosceles triangle, the two sides are the same and the two angles are the same. Okay. Awesome. Good job. It's fun learning about proofs.